So today what we're going to be finding is the equation of a perpendicular line that goes through a certain point. Now, the big concept that what we have to remember from perpendicular lines, what we've covered previously, is that perpendicular slopes are what we call negative reciprocals. This comes from two different ideas. Negative just simply means that one's positive, one's negative. It doesn't mean that the perpendicular slope is always negative. It means we're going to change the sign. So if it was positive, we'll make it negative. If it was negative, we'll make it positive. This also means the reciprocal is their flipped versions of each other. So the idea of 1/2 and 2/1 or 2 are reciprocals of each other because we're looking at things on opposite sides of the numerator and denominator. So let's go ahead and take a quick look at what we have over here. If we're looking at a line that's perpendicular to y equals 3x plus 7 and contains this point, we need to first find our original slope. So this is in y equals mx plus b format. So I know that my slope is going to be the number attached to the x, 3. So what I'm going to do is I'm going to say, okay, if my original slope, m1, is 3, in fact, I'm going to even make this a fraction. My original slope is 3/1. My slope that I'm going to be using is going to be a flipped version, so 1/3. I flipped that upside down, and I'm going to change the sign. So I've reciprocated it. Now I'm going to change the sign. That was, let's see, 3/1 was a positive number, which means that my new slope is going to be a negative 1/3. And it's going to contain this point. So all that means is that I'm going to have to use my point slope formula. So y minus y1 equals m times x minus x1. Cool. So I'm going to say y minus, actually, let me go ahead and fill this out so we can do this a little faster. Y minus my y1 in this case is going to be an 8 equals my slope, which is negative 1/3, x minus my x1, which is going to be 3. Perfect. So I've got 2 steps to solve this. I'm going to go ahead, I'm going to combine these two by distributing. So y minus 8 is negative 1/3 x. Let's see, 1/3 of 3. Let's see, I know that negative is going to end up being a positive, and those 3's are going to turn into a 1/1, so it's going to end up being a positive 1 plus 1. Perfect, and I'm going to add 8 to both sides. So I get y is equal to negative 1/3 x plus 9. There we go. Let's do one more version of that. I'm going to go ahead and I'm going to take my slope, which in this case is a negative 15, because it's in the original y equals mx plus b formula. And I know if my first slope is a negative 15/1, that means the slope that I'm going to use is changed. So m2 is positive, flipped 1/15. I'm going to use that slope. I'm going to plug it into my y minus y1 equals m times x minus x1 formula. So I get y minus x minus. In this case, my y1 is a negative 7. My x1 is a 30. And my slope that I'm using is a 1/15. Now it's positive, so I don't actually need to draw the sign. I'm going to distribute this 1/15. I'm also going to notice that double negative means that y is actually plus 7. So a 15th of 30/1. Well, I know that those reduce. 30 divided by 15 is 2/1. So 1 times 2 is actually a 2, or just 2. So 1/15 x minus 2. Perfect. And if I keep this going, I'm going to subtract 7. Cancels that out, so I have y is equal to 1/15 x minus 9. Perfect. And so this one's already set up in a fraction for your original slope, so I want you to go ahead and pause the video real quick, try out number 5 and see how well you do. Unpause the video when you're done to see how you did. Okay, so I know right here I have a slope of 1/2, and it's a positive 1/2. So I know my new slope, if my first one is positive, this is going to be a negative, and I flip it, so -2/1, or just -2. Don't need to put the over 1 if I'm just finding the equation. Okay, plug it into my formula, and I get y minus, let's see, my y1 in this case is 16. My slope is -2, and my x1 is -4. Okay, so my first notice, especially if I have minus and negative, it turns into plus a positive. And so let's see what we get. -2 times x is -2x. -2 times my newly positive 4 is going to be a -8. Okay, in this case I'm going to add 16, which means y is equal to -2x plus 8. Boom. There we go. So let's try one. Now these next two are going to be, I guess you'd call them challenges. I have a 3/4. It's not a whole number. It's not a simple fraction. It's going to be a little more of a challenging fraction, but no worries. I know if my original slope is a positive 3/4, I know my new slope is going to be a -4/3. I'm going to flip it. Can't actually reduce that, so I'm just going to go ahead and plug it in. So y minus my y1 of 16 equals the slope, -4/3, x minus x1, -24. First thing I notice is minus a negative. And I'm going to go ahead and I'm going to distribute to my newly positive number. First off, -4/3 times x is just -4/3 x. This is the part that's curious. So my -4/3, so -4/3 times my newly positive 24/1. I'm going to go ahead, I'm going to cross reduce. So 24 divided by 3 is 8/1. So it's actually -4 times 8, which is -32. 1 times 1 is 1, or just -32. A separate way to look at that is saying, okay, 24, I'm looking at a fraction right here. I could say that 24/4 I'm multiplying and dividing. Why don't I just take that in 2 separate pieces? So I'm going to divide first. So 24 divided by 3 is 8. And then 8 times -4 is -32. We are both dividing and multiplying. Dividing and multiplying is just a way of showing a fraction. -32, -32, boom. Brings us to our last step. Y is equal to -4/3 x minus 16. Perfect. And the last one, having a decimal, is what could be the most difficult. So take a second and see how we would find a perpendicular slope to -2/10 or -0.2. Think about how we do that. Unpause the video when you're done. See what our solution was. Okay, so what happened is I may have given it away when we read what this number is. If we remember way back when in like elementary school, we know that, let's say a big number like this, we know that this is what we call the ones, this is what we call the tens, this is the hundreds spot, this is the thousands, and it keeps going up and up and up. We know that anything after a decimal is what we call the 10th. The next one is the 100th. Now, this doesn't actually just come out of nowhere. This is how the fraction is set up. So what I know is that I'm actually dealing with a line of y equals negative 2/10 x plus 1.5. So I have something that I can flip. So if my original slope is negative 210, let me actually write this out. Then I know my new slope, first off, if that was negative, my new slope is now positive. Flip it, 10 over 2. 10 divided by 2 is 5. So my new slope is actually just a 5. And I'm going to take my new slope, my point, plug it into my point slope formula. Y minus my y1 is negative 15. X minus my x1 is 10. My slope right here is positive 5. So I do two things. I notice that minus a negative becomes plus a positive, and I go ahead and distribute the 5. So 5x, 5 times negative 10 is negative 50. So we get y is equal to 5x minus 65. And there we go. Okay, so today we're going to be doing graphs with limited domains. What this means is we're going to be graphing these lines, and we're going to be graphing them in a pencil, and we're going to be graphing them very lightly because we're going to be erasing a good bit of each one of these lines. Because a limited domain means we're going to have walls on each side of the graph, and we're only looking at the point on the graph that's between two values. Actually, it might be best if I show you via. So a limited domain means I'm only going to look to the right of a certain number and to the left of another number. So even though the graph I know extends behind the two barriers, we're not going to actually include it. So let's go ahead and let's get started to see how this works. Now, this graph is listed in interval notation, which means after the semicolon, I have a starting point and a stopping point. Now, the starting point and stopping points have one of two things, either parentheses like this one, which are going to be open circles. So a parentheses to a parentheses is going to be an open to an open with a line between. If I have brackets like on the following one, those are going to be included points, which means I'm including the boundary point itself. So I'm going to go from point to point. And so keeping that in mind, let's go ahead and let's push forward. So again, I recommend doing this in pencil because you're going to be erasing a good bit of the graph. So from right here, I have a line in y equals mx plus b format. So y equals mx plus b format. I know my b is 1, which means my intercept right here is at 1. And my slope is 3/4, which means I'm going to go up 3 over 4. If I don't have room to go up and right, I'm going to go down 3 and left 4. And I'm going to graph this. Now remember, we're graphing this very lightly because most of this is about to get erased here in just a second. So I have that. And so let's take a look. I have boundary number 1 at negative 4, which means I'm going to be drawing a boundary at negative 4. So, albeit you don't actually need to show where the boundary is, I'm going to highlight the boundary here in pink just to show you where it is after I remove the card. So technically what we're doing is we're saying, hey, only concerned with that part of the graph, which means I can erase that part way down there. So that's exactly what we're going to do. We're going to erase that part over there. The second boundary that I have is at positive 4, which means the graph from this boundary is going to keep going until I hit positive 4. So 1, 2, 3, 4. And this is actually the only portion of the graph that I care about is this middle section. So I'm going to go ahead and I'm going to draw a boundary right here. Again, you don't actually need to draw these boundaries. This is just me visualizing what is going on. So I don't care what goes on after the boundary, so I'm going to erase it. So boom, I have my graph. The only thing left that I have to do, let's do this in blue, is I'm going to say my starting point at -4 is not going to be included, so it's going to be an open circle. Neither is my ending point, so that's also going to be an open circle. And I'm going to include every point between there. Perfect. So rightly and truly, the graph that I'm showing right here is just what's in blue. If you ignore what's in pink, it's just this middle section. So, that being said, let's try one more of those. Let's go ahead and graph this. I know I have a b of -1. I have a slope of -1/2, which means I go down 1/2, down 1/2, or up 1, back 2, up 1, back 2. And we're going to go ahead, we're going to connect all these points with a straight line. But again, we're going to draw it very lightly because we're going to erase a good bit of this. And again, so now with these boundaries, I have a boundary from -4 to +2. So I only want this portion of the graph. I can erase everything else, which means that my rightward boundary at -2 is right here. My leftward boundary at -4 is going to be right here. And I'm only concerned with the graph that's between those two boundary lines, which means I can go ahead and erase anything on the outside. The only difference now is my boundary point right here is included because I have a bracket, and we remember that brackets mean included points. And my 2 point is also included. We're going to go ahead and we're going to shade all of this in between. So there we go. We have our graph. And so what I want you to do is I want you to go ahead and pause the video, try number 5, unpause it when you're done, and see how you did. Okay, so let's take a look. Now, this is in y equals mx plus b format, but I don't see a b because I just have y equals 2x, and then I have my boundary lines. So that means if I don't see a b, my b must be 0. But I do have a slope of 2, or 2/1 if I want to draw it that way. So I go up 2/1, up 2/1. If I don't have room, I go, instead of up and right, down and left, down and left. I'm going to go ahead and I'm going to very lightly draw that on there. I have two boundary lines, one at -1 and one at +1. So I have a very small portion of this graph. In fact, anything outside those lines, I can just go ahead and erase. I'm only concerned with that little piece right in the middle. And then unlike the prior ones, this left boundary is going to be open because I have a parentheses, which means it's not included. However, the right one is. So I'm going to go ahead and shade in the right one, which means that if I were to graph this, all I would really graph would be that little blue piece right there, open to close. Perfect. So now that you got the gist of it, let's look at one other format that we're going to be including today. Now, this format is in point slope form. And if we remember, let's go ahead and write this up here. Point slope format is y minus y1 equals m times x minus x1. I have two options for graphing this. I could simplify this, which would mean what I'd do is I'd go ahead, I'd distribute the 1/2. So y minus 1 is 1/2 x minus 1/2. Then I would add the 1, so y is 1/2 x plus 1/2, and I would graph using this. Or I could recognize that I'm given my slope right here. So I have my slope, and I know that my point, if I plugged in a point of, let's say, 5, 2, I know the way that would look, it would be y minus 2 is some slope times x minus 5. So now if I plug in a positive 5, it's going to look negative. If I plug in a positive 2, it's going to look negative. On the flip side, if I plugged in a negative number, it would look positive. So I can just look at this without having to do this math right here, without having to worry about any of that, and say, my x value is the opposite of that. So it's going to be a 1, comma, the opposite of that, 1. So I'm going to go ahead and put a point at 1, 1, and use my slope from there. Up 1 over 2. If I don't have room for up and over, I go down and back. And so that's the trick on reading point slope. So I've got my points right there. I use my slope, and I use the opposite of what I see as my point. Let's go ahead and put my boundaries. I have a boundary right here at -3, and a boundary over here at +3, which means I don't want anything on the outside. But I do want that point. I don't want that point. But I want everything between these boundary lines. And there we go. So that having been said, I want you to go ahead and give this a shot on this one and try graphing this without simplifying it. Graph it from point slope format, and we'll look at what's going on with the boundary here in just a minute. So take a moment, try and graph that line just looking at the equation. Okay. So what I see here is I see a slope of 1/2, and I see a coordinate. Opposite of 2 is -2. Opposite of 1 is -1. So I'm going to go ahead and graph a point at -2, -1, and go up 1 over 2 from that point. If I don't have room for up and over, I go down and back. And graph a very light line between them. Now, I'm going to put a boundary at 2. I know because 2 is my left number, I know that's going to be my left boundary, which means I'm not including any of this over here. But what's interesting is that my right boundary is at infinity. So I'm going to take this paper and I'm going to put it at infinity, which means, does this graph actually have a right boundary? No, it doesn't. This is showing us that the graph starts at 2 and goes on forever in the right direction. So let's go ahead and erase all of this because we know it starts at 2 with an open circle, and it goes on in the right direction. How do we show that the graph goes on? We draw an arrow. It says, hey, there's more over there. Perfect. And so now that you've had another shot, go ahead and try this one. You should be pretty good at this point. Graph this line without simplifying it, just looking at the equation, and with these two boundaries. And think of what we did up here when the boundaries were at infinities. Okay. So here I know I have a slope of 3/4, and I have a point which is opposite 4, so -4. Opposite -1, so +1. Don't actually need to put the +1, I just kind of did. So -4, +1, and I go up 3, 1, 2, 3, over 4. So I have a graph that's doing this right here. Okay. Now, the fun part about this is I see a boundary point at 0. Which is right here in the middle. But that's my right boundary. It's the right number. It's the second number, which means I'm covering up everything to the right of it. That negative infinity means that because that's my first point or my left boundary, I'm going to take my left boundary and throw it at negative infinity. Way over there. So does this graph actually have a left boundary? No, it doesn't. which means this graph comes from way over here at the very, very, very beginning of the graph, very beginning of time, wherever you want to look at it, and stops. So it has no beginning, but it does have an end. Stops right there. So how do we show that the graph has no beginning? Well, we put an arrow and say has no beginning, but it does have an end at 0, and that end point is included. Boom. And there we go.